Senior Solutions Architect at Bright Computing. He'll be talking to us about Bright Cluster Manager and PBS Professional, extending clusters into the cloud with data-aware scheduling. Please welcome Robert.
Hello, everybody. I'd like to thank Altair for inviting Bright Computing to this first ever event. We're very pleased to be here. My name is Robert Stober, so I'm a solutions architect. I work for Bright Computing. And today I'm going to be telling you about Bright Computing's integration with PBS Professional, in particular with our cloud bursting and data-aware scheduling. So I give this presentation quite often. It's part of my job to folks all over the country. Normally it takes about an hour and a half to go through the whole presentation, so this is a much trimmed down, you can thank me, much trimmed down presentation. I'm only going to have a few slides about Bright in general, and then I'm going to focus very specifically on cloud bursting and scheduling data to the cloud, which is something that we're very proud of at Bright. So I'll start off with this architecture slide. This is a representation of a typical Beowulf-style cluster. I don't want to give the impression that this is the only architecture that we support. It certainly is not. We support flat architectures as well, right out of the box. But this is what we run into most often. So you have a head node with at least two network interfaces, an external interface and an internal interface with the compute nodes connected on a private network, right? So we also have a Bright Cluster Manager daemon that runs on each one of the nodes, on the head node and each one of the compute nodes. It's a lightweight daemon, uses up less than 50 megabytes of RAM, very streamlined in HPC firming. And the daemons communicate with each other using SOAP over SSL. Internal to the cluster, we use a null cipher just to minimize the overhead of encrypting messages that are sent back and forth. External to the cluster, however, you connect to the cluster with the cluster management GUI or your cluster management shell. All those messages are encrypted. And by the way, for any of you DoD people who have higher security needs and you need the messages internal to the cluster to be encrypted, or if you're not using this architecture, we can certainly turn on the cipher so that the messages internal to the cluster are also encrypted. Our daemons communicate using the SOAP API. You can use that SOAP API if you wanted to create your own application, let's say, right, to manage the cluster or to interface with the cluster. So on the other hand, if you don't want to use SOAP, you can use one of our interfaces. So we have Python, PHP, and JSON interfaces to the API as well. Web-based user portal that we provide right out of the box is built using the PHP interface. So if you were to install Bright on your head node, and then you cd to var HTML and www user portal, you'll find a bunch of PHP files in there that access the cluster management functionality, and you can easily extend that. So our web-based user portal provides a lot of the information that John was just talking about in terms of the users being able to see what's going on the cluster, what jobs are waiting, what some simple charts or stuff like that. But it can be extended to do pretty much anything you want. Third-party applications, I think I pretty much already talked about that. So let's go on. So we do provide two management interfaces. They both provide the administrator with full control over the cluster. Which one the individual uses really is a matter of choice. I personally use them both. The graphical user interface, you'll hear me refer to as CMGUI, is a standalone desktop application that runs on Windows and Linux. The next version that's coming out right about the time of supercomputing will also run natively on Macintosh. It'll be using our new JSON interface. One of the advantages that Bright has over other cluster management solutions that are out there is the ability to manage multiple clusters simultaneously. So using a single instance of the Bright CMGUI, you can connect the clusters running right next to you across campus or all the way around the world and administer them all from one central point, and even share configurations between them so that it eases your administrative burden and provides a more consistent administrative environment. Our GUI uses the Mozilla Zool engine. On the other hand, we have the cluster management shell. It has the same functionality as the GUI does, so really, like I said, it's just a matter of choice which one you use. It is an very minor and obvious. For example, using our cluster management GUI, you can access graphs, charts, and metrics that we've collected. Using the cluster management shell, you can't access the charts, but you can access the data. On the other hand, you can run the cluster management shell as a batch program, right? You can type commands into it, you can give it arguments on the command line, you can give it a file with a list of commands in there, it'll execute them one at a time. You can embed it into other scripts. You can use shell redirection, history, tab completion, and a for each loop, and so on inside the CMSH, and it has access to all the objects of the cluster, node groups, node categories, nodes themselves, and so on. You can iterate through them and operate on a wide range of cluster objects all simultaneously. So it's much faster if you know how to use it, right? It's got a higher learning curve than the C and GUI does, but on the other hand, once you learn how to use it, it's more powerful, typical of a shell, application. So this is another way to look at the Bright Cluster Manager. You have the cluster manager sort of in the center of the universe here, surrounded by the security layer. I already talked about the SOAP. Well, when you connect to the cluster using one of our either CMSH or our CMGUI, you do so using X509 certificates along with the password. So that is what encrypts your communication back and forth to the head node, provides very secure authentication. On the other hand, we have a firewall running on the head node that only allows certain ports in. Inbound traffic, port 80, port 443, port 22, port 8081, which is our default daemon port. And of course, you can modify the firewall, but that's how it comes out of the box. And then our cluster management GUI and our user portal and our cluster management shell connect to the cluster management daemon on the head node through that security layer. The CM daemon itself is running on an operating system. We support Scientific Linux 5, Scientific Linux 6, CentOS 5, CentOS 6, RHEL 5, and RHEL 6, and SLES 11 SP2. And of course, they're running on top of hardware. So whatever hardware those operating systems support, Bright supports as well. And then Bright has numerous other services on top of the operating system, on top of Bright, one of which is provisioning. So with Bright, provisioning is not something that you just do when you first turn on the cluster, right? When you first provision the cluster, but you use provisioning throughout the whole lifetime of the cluster to maintain the software load set on each one of the compute nodes. So if you want to install software to a group of nodes, you install it in the image, you push those changes out using a single command for CMSH or a single button in our GUI. Workload management. So we have a tight integration with PBS Professional. So when you install Bright, you'll have the opportunity to install PBS Pro. It even comes with a 90-day trial license, which is just totally cool. So you just select PBS Pro from the drop-down GUI. When you get done with the installation of Bright, PBS Pro is running on your head node and all the compute nodes that you install. You can immediately start using it to run jobs. So incidentally, I meant to mention in the first slide, let's go back a little, rewind just a minute. The purpose of Bright Cluster Manager is to make it really easy to install high-performance computing Linux clusters and then manage them over their entire lifetime. That's what we're trying to do. We're trying to remove the complexity of cluster management, even though it is a very complicated subject, right? And we're also removing the complexity of using a public cloud, which is also extremely complicated, but we make it easy. And the same thing here with this installation of PBS Pro, automatic configuration, and I'm going to talk more about that in a slide coming up. Health management framework out of the box, right? Provides the health management framework that includes collection of metrics, running of health checks, and the ability to automatically take actions if a metric exceeds a certain configured threshold or a health check fails, for example. There's more than 140 metrics we find out of the box, more than 24 health checks, a dozen actions, and they're all totally accessible. So if you wanted to collect something else or run a different health check, you can easily do that. And finally, all the compilers, libraries, debuggers, profilers, MPIs, Linux environment modules, everything else that you need to actually use the cluster, it's all there. Like I said, it's a turnkey solution. As soon as the cluster is installed, you should be able to use it right away. So this is what it looks like, right? This is a screenshot of one of our development clusters. And so what I wanted to highlight here is that the left-hand side there, you'll see what we call the resource tree. And this is a big differentiator between Bright and other cluster management solutions or other roll-your-own type solutions that you find out there, is that Bright allows you to manage and or monitor to one extent or another virtually all the components that comprise a high-performance computing cluster, including the cluster itself, but also manage switches, power distribution units, including ILO, DRAC, IPMI, multiple software images, networks, node categories, multiple head nodes. I'm only showing one here, but with Bright, you have the opportunity to have a secondary head node as well. You configure automatic failover between the two. Racks you can manage, chassis, virtual SAP nodes, obviously compute nodes themselves, cloud nodes, which is really the star of today's show. Other devices that speak SNMP, node groups, users and groups, workload management. So we can manage the workload manager to a certain extent through Bright. And authorization and authentication. So this is an overview screen we're looking at here, but I'm not going to spend a lot of time on this since I only have half an hour of it. Basically, the way this works is that whenever you select a resource in the resource tree, the functionality that that resource provides is it shows up in the right-hand side in the content pane through a series of tabs, right? So as you can see, we've selected one of our compute nodes, and you see the tabs there: overview, tasks, settings, system information, services, process management, network setup, mounts, exports, and there's more stuff that's not shown over there. Burn, configuration, nodes, and roles, I believe, are cut off from this picture. But note that on the task tab, which is selected, I can take all these different actions. So this is the action tab, right? So from here, I can power cycle a machine, or power it on, power it off, do an operating system shutdown or restart, assign it to a node group. There's the update node button. I mentioned that if you wanted to install software on a node, you install in the image, you push a button in GUI or run a command. There's the button you can press to update this one node. Now, if I had selected a node category instead, which would be a whole group of machines, I would also have a task tab like this, and it has an update button, and I can update all those machines at once, so we can do it either way with Bright. I can force it to do a complete reinstall. I can log into this node and install software on this node, and then press the synchronize image button, save those changes back to the actual image itself, or I can make a clone of an image, and then install software on this node, and then press the grab to image button, and save the running state of this node back to the cloned image, and then I would provision the node to try it out. So that's the general idea there. I can drain the node from a workload management point of view. That means don't send any more jobs there, or I can undrain it. I can open up a root shell. If I've configured console or shell or LAN in the image, then I can open up a remote console, see all the console messages, watch the thing boot, and so on. I can open or close it for the purposes of monitoring. I can locate it in the rack. We have a rack view. I don't have time to show you everything, but we have a rack view that shows where all the nodes are in the data center. This would highlight the node in that rack view. Look at the provisioning log, run any of our health checks. So there's a whole bunch of health checks that are defined for the default node category. And I can run any of them right from here, right now, and get the output, or I can run them all. Finally, what's not shown on here is the workload manager integration. So Bright does a number of things with PBS Pro, both starting from when we first did the installation. I mentioned the drop-down box, right? So you select PBS Pro, you select how many job slots, for lack of a better term, you want on each one of the compute nodes, and whether or not you want the head node to be to run jobs or not. Going to the next stage. When you get done, Bright has installed PBS Pro, it's running on the head node. When you turn on your compute nodes and provision them, they'll also become part of the queue. They'll be able to run jobs on them right away. Automatic configuration. So when you add nodes to your cluster, they automatically get added to the PBS Pro configuration files. When you take nodes out of the cluster, they automatically get removed. In addition, there's a couple of resources that we add too. We're going to talk more about those in a minute. Sampling, analysis, and visualization of workload manager statistics. Admittedly, this is pretty basic stuff. Running jobs, pending jobs, completed jobs, exited jobs, expansion factor, estimated delay, and the actual health check status of the mom on each one of the nodes. We actually do a PBS command, I believe it's qstat, to make sure that the thing is actually not just the process of running, but it's actually responding. Probably like it's supposed to be clear out to run that command automatically, so that the administrator is alerted if the mom goes down on one of the nodes. In fact, we actually restart the mom as well if it goes down. Consistent GUI user portal and command line access. So here we can see the jobs that are running. We can control the queues to a certain extent. We can drain or undrain. We can assign nodes to queues and so on. All that from either one of those places, not from the user portal, but from the command line or from the GUI. Numeric GPU resource, so we automatically create this GPU resource. And obviously they specify the GPU's resource and how many they need, and then PBS does its job and sends the job to one that has that. Failover with the workload manager, so the PBS failover automatically fails over to the secondary head node if you have that configured. Otherwise, your normal PBS failover will work. Health checking. I mentioned health checking already, but I wanted to add on pre-job health checks. So we have the health check framework already. A bunch of health checks are periodically being run. Then we have this idea of the pre-job health check, which addresses what we call the black hole node syndrome. And I think I heard you call it the black hole node syndrome as well. So the black hole node syndrome, for people who don't know what it is where you have a cluster and you have a workload manager running and the users are submitting the job just like they're supposed to. Everybody's happy, right? Waiting in line, everything's cool, except that one of the nodes fails in a subtle way. For example, let's say one of the project directories is supposed to be mounted isn't mounted, right? But that means that when the job goes there, it'll start and it'll immediately exit. And then the PBS will say, okay, I got an open job slot, takes the next job and it exits. Before you know it, you can lose 10, 20, any number of jobs, right, through this black hole node. And the problem is, as the administrator, you can't actually fix the problem. You can't restore people to how they were, how they should be, right? Because a bunch of new jobs are now running. What are you going to do? Go back and fill those jobs and put these jobs back? And even if you did, there's more of them that exited than you have available job slots. So really, the only way to solve this is by solving it ahead of time. So what we do in Bright is we actually prevent it from being happening. We allow it from happening in the first place, right? We allow you to define a health check, let's say a mountain health check that gets run in between the time the job is dispatched to the node by PBS and the time the job starts running, the pre-job health check runs. And if the pre-job, and it can be more than one pre-job health check too. If it fails, then it gets re-queued back to the top of the queue. The job is not run there at all. And that node is drained, so no more jobs are sent there, and you get alerted. So you can go fix the problem, and the black hole node syndrome is cured before it causes any problem. So we're proud of that. It's a very generic interface. I think you'll find it quite useful. So that brings me to cloud bursting. So there's another resource that Bright created that there's actually a couple things that Bright did that I didn't mention in the last slide. And one of them, and they all have to do with this cloud bursting, right? So Bright really sees two scenarios of cloud bursting. One is where the entire cluster is actually located in the cloud. That's not what I'm talking about today. I'm talking about the scenario where you have a local cluster, and then you have a period of time during the month or every quarter or maybe just for a one-time project when you need more resources, right? You just need them right now for a short period of time, let's say, or you need them in advance of a purchase that's coming up. And that's where this cluster extension scenario comes into play. There's your local cluster. You want to add some resources. From within Bright, you click on that little cloud nodes resource, and you start this process going to where you can actually just add cloud nodes. And these nodes will actually come up in Amazon. It takes 5 to 10 minutes for them to be allocated, for them to get provisions. Bright will automatically create an open VPN between the head node and the cloud nodes. And so it's quite secure from that point of view. PBS Pro will automatically be started on those nodes, and jobs can actually start running on them right away. Of course, there's some caveats that we're going to talk about as we go through, but if you had a very simple PBS Pro job that the data files were already up in the cloud or something like that, right, they could immediately start running. And so these nodes in the cloud behave in all respects just like the local nodes. You saw that picture I showed a little while ago where I had the node selected and you had all those buttons and everything. Well, those same buttons are available for the cloud nodes. So if you wanted to install software on the cloud nodes, just go to the image, install your software. Basically, RPM --root equals whatever the path is, -IBH or mypackage.rpm, and then you push the button. It gets propagated out to your local nodes and out to the cloud nodes if they're in that node category. So immediately the change is made, and you can remove software the same way. You can use yum --install root. You can do change root into the image and run make and make install or whatever. I think I beat this one to death. Anyway, they're just like your local nodes is the point, right? So you can administer them and use them just like you do your local nodes. So this is the way it works. I'll walk you through a short scenario here of how this works. So I've selected my cloud nodes resource in my resource tree, and I've accessed the cloud accounts tab. Now here, I've actually already created an account, right? Because, anyway, I've already created the account. So what I'm going to do is show you, I'm pressing the edit button. See that little pencil up there? That allows me to edit the account settings for an account that's already set up. But let's presume that instead of add a new cloud account button, I get a dialog like this. I put in my Amazon credentials, right? I give it an arbitrary name. I put in my Amazon username, my account ID and key that they gave me, etc. I can see what my password is by clicking that show password. I can see all the numbers if I click that show password box. This won't do any good, by the way, unless you have those. I can specify my default region, so you can use all the different Amazon regions simultaneously if you want to inside Bright. Most people don't do that, but I'm using US West 1. Note the default type, so this is a development cluster, so I'm using the cheapest possible Amazon instance type, which is a T1 micro. It's very small, it costs like, I don't know, a penny an hour or something. But it's perfect for my purposes. And then for my cloud director, I'm using the M1 large Amazon instance type. Now note that on those drop-down boxes, every Amazon instance type is supported, from the smallest ones to the largest compute instances. You can select them here. And the same thing when you go to create the cloud nodes in a moment. But I haven't told you what a cloud director is. Okay, so let's go into that. After I press OK and walk through a few more dialog boxes, the very last step of this will actually create something that we call a cloud director. Okay? So a cloud director is a node that runs in the cloud in a region that performs some of the functions in the cloud that are normally performed by the head node in your local cluster. Some of the things that it does. Well, first of all, it serves as a gateway between your local cluster and the cloud. It provisions the software images to the cloud, so it has a copy of the images that you want to use on the cloud nodes already on itself, right? So when it boots up, it acts as a provisioning server for the nodes in the cloud. Basically, the way it works is that the Bright AMI starts up. The Bright AMI is it's an Amazon machine image. It connects to the cloud director, and then it does a regular rsync type provision like Bright does. It serves as shared storage for the cloud node, so it shares a directory called /cm/shared, which is where we put a bunch of applications and so on by default. It also shares the home directory of the user in the cloud, so we don't mount these directories from the local up there. Instead, we synchronize the CM shared directory up to the cloud, and the home directory is a local home directory. It's shared locally within a cloud region. It also mirrors some of the network services, some of the services that are normally provided by the head node of your local cluster, like DNS and LDAP. And then the cloud node booting process, I've sort of already explained it. Basically, the instances have these at least one EBS volume that's persistent that retains, in between boots, it continues to exist. And it also has another disk, which could either be PBS or ephemeral. The Bright AMI goes on the first disk and 1 gig disk. And then it's a regular node installer process after the EMI boots up, which we can get into, later, I guess. But basically, the software image gets provisioned onto the second disk, and then if it's an EBS volume, you can turn that machine off and turn it back on again, and it'll already be provisioned. It'll just synchronize with the cloud director. If it's an ephemeral disk, then when you turn it off, it goes away, and then when you turn it back on, it's like diskless, right? It gets re-provisioned. This is a picture of what it looks like. It actually isn't quite this complicated. But this shows a couple different availability zones, right? So this is, if you had 2 availability zones, then Bright creates a cloud directory in each availability zone or region, right? And you have a VPN between all of them. So this VPN is very cool. What it means is that you don't have to open up any ports in your firewall, right? So if you want to access a license server, let's say, right on your local environment, you can do it because you have the VPN. All you need is port 1194 outgoing, UDP, in order to set this up. So if you don't have 1194 outgoing UDP, and I've learned this lesson 2 times the hard way, it won't work. So you have to open that port up. And we're going to talk about how we might be able to mitigate that. But as of right now, that's the only requirement. The only port we need is 1194 outgoing UDP. We can set this whole VPN thing up. Let's see what this one says. Right. So we're going to talk about this. The cloud nodes behave exactly the same way as the local nodes. They provision exactly the same way. They have the same software image. They have the same user environment because the LDAP database is replicated to the cloud nodes. They have the same workload manager setup, the same management interface that allows us to control them and administer them, the same monitoring and health checking scripts that run, collect metrics, etc. And everybody can talk to everybody. So I can be on a cloud node and do an SSH to a node in my Beowulf style cluster behind the head node. And I can log in without a password, SSH to them there. Same thing if I'm on a local node, right up to the cloud node and so on. And this is all accomplished by VPN, routing, DNS, etc., network mapping. Frankly, it's pretty complicated, but for end users, and I'm an end user in this case, it's pretty simple. It just works, right? It's pretty cool because if you're on the head node and you ping a cloud node, you get one IP number, right? But if you're on, I don't know if that's a good analogy or not. Let's say that you are on the head. If you're on the head node and you ping the cloud node, you get one IP number. If you're on the cloud router and you ping the cloud node, you get a different IP number. But they both resolve to the actual same host, and it's all very transparent the way this whole thing works. The VPN setup I already mentioned. Okay, and so single DNS namespace. And this is so now after we finished, that was a little digression there. We finished the dialogue. We got a cloud director installed, and as this last step, it actually starts running. It takes a little while to finish that last step because we upload like 7 gigabytes of data, right? Images and shared storage, and then another image. So basically, it takes a while depending on the speed of your disk. But once it comes up, then you can actually create nodes. Actually, you can create the nodes before it actually comes up, and you can't turn them on because the node's provisioned off the cloud record. At this point, though, all we did was click on the Create Clouds Node button, and we get this dialog. And so what I'm doing here is creating 4 cloud nodes, 1 through 4. I selected the cloud category, which you don't have to do. I just have a cloud category of my own. I've changed a couple of things on that. I select my region, my instance type, if I want to override the default, right? That's why it says that, because I picked that as a default. I say what my storage size is, etc. I press the next button. Now, note that the cloud nodes are showing up in my resource tree now, but the little blue arrows indicate that they're down. These nodes are created as software objects within Bright, but they don't exist out in the cloud yet. So as soon as we press that power on button, then they're going to be instantiated out in the cloud. And they're going to come to life. And it'll just take, like I said, like 5 or 10 minutes, and they'll be up and running, as they are right now. They're up and running, and notice I've selected my task tab again on a different node. But note that, the same buttons are there as they were on the previous tab. So I can pretty much do everything here, including workload management. So the workload management daemons, PBS Pro daemons are running now. And if I submit a job, it could potentially run out there. And so I want to control that. So Bright automatically creates this resource, the cloud region resource, right? Defines it in these 2 files automatically. You can see it there, cloud region. So just say cloud region equals US West-1, let's say, right? That specifies the cloud region. There's my QSub command line. If I run that QSub command, then my job can potentially run on those cloud nodes. And that sort of, going back to this picture, it looks sort of like this. User submits the job to the queue using the command like we used a minute ago. The next step, PBS dispatches the job to the cloud. And that's it. Sounds pretty good, right? Of course, if the input files the job needs aren't there, the job's not going to work, right? It's going to exit. And also, the job's going to write output files, which presumably somebody needs to look at. We need to deal with that, right? So there's a couple different ways we can do that. Number one, we can use a job script. Right, so here I am in my job script, and what I'm doing is I'm copying the input file up there, up to the cloud node. Then I'm running my job, which is just catting the input file. And then I'm copying the output file. That's the standard job name convention, right? I'm copying that back to the submission directory. This is pretty fine. It works good for simple cases. And so you can do it this way. However, Bright provides one more thing called scheduling data to the cloud. Sometimes you'll hear our salespeople refer to it as data-aware scheduling. I think it's more, scheduling the data itself. And so here's the way it works. Starting with the same picture again, this time the user submits a job using a new command that Bright provides called cmsub. And what cmsub does is it actually submits a couple of jobs. First of all, it submits 2 data transfer jobs. And both the compute job and the final data transfer jobs are dependent, right? So the first data transfer job will transfer the data files that are required up to the cloud directory. So what it'll do is like let's say you're in your home directory /directory 1, and then you have a file, right? You specify that in your cmsub command. It's a script, like a job script. It will copy that file up to the cloud, Then it will run your dependent real job, right? And then it will run another job that will transfer your output files back down to your local directory. So it just makes the whole process real simple. So the user submits, so here's the data transfer job, and then the compute job runs, and then the dependent job transfers the data file back to the cloud node when the job is completed. So this has a couple of advantages over the putting the statements in the JavaScript method that we mentioned earlier. First of all, it's a lot simpler. That other way can get pretty complicated pretty quick, right? So this way allows you to specify individual files or entire directories or multiple entire directories, or you can give it, a file with a list of directories and files to copy up, and the same thing copying back down. You can specify a certain cloud region. You can specify whether to keep the files on the cloud nodes or to delete them, etc. It's an integral part in the very last step of this whole. This is what a CM sub command looks like. It looks just like a JavaScript with CM sub arguments in there. There's your file that I'm copying up. There's the region, the file that I'm copying back, the workload manager, and then the arguments that I'm passing to the queue sub command, and then my command itself, stress-cpu.shell. And then I submit it with CM sub JavaScript. CM sub is going to write the PBS Pro JavaScript and automatically transfer it up, so I don't have to specify that. Also, it'll automatically transfer the standard output file from PBS back to the local, so I don't have to specify that either. I can specify other files that I want copied. And so as soon as I'm done with that, then you see the jobs that are submitted within the Bright Cluster Manager CM GUI. And by the way, everything that I'm showing you in the GUI, you can also do from the shell, but it's not as easy to see as it is in the GUI. So that's why I show it here. But here you can see that the real jobs, the first set of data transfer jobs happen so fast that it's really hard for me to actually catch them, right? But if they were really big files, obviously you see them in there. So they've already run. So now what you see is the actual jobs that are running, and then the cloud transfer jobs that are dependent on the actual jobs running in order to transfer the data files back down. And then, from here, from the CM GUI, we can get detailed job information on a job, fill a job, we can suspend a job, resume a job, all your basic stuff, as you might imagine. So there's one more thing I wanted to talk about, actually, and I don't have a slide for it because it's top secret. Yeah. No, it's workload-driven dynamic cloud provisioning. So what that is it's a new thing that I just implemented last week. I didn't write it. I didn't write it, but I did implement it at a major customer for a POC just last week, and it worked pretty good. And basically what it is the users, we'll add one more element. The user submits a job to the queue using the CM sub or the standard queue sub command, and Bright will actually go out there and start the cloud nodes that are required for the job, right? And then it'll transfer the data files up, and then it'll run the job, and then it'll terminate the cloud nodes after transfer the data files back. Then it'll terminate the cloud nodes. So it's fully automatic. As it is right now, you have to start the cloud node, and then you run the job. Which is still pretty cool, but as soon as you say that, people say, well, I just want to submit the jobs and have Bright start the cloud. Okay, we can do that now. And then it puts them away, and there's some policies you can configure on how many to start as a maximum, etc. And I'm sure that over time there'll be a lot more policies. It looks like I've gone over my time limit here, so you get the hook.
So maybe time for one question, if there's one question.
We'll have a table here tonight, so if anybody wants to come by.
All right, if not, thank you very much.
You're welcome.